Picture this. Billions of years ago, our story begins in a massive, swirling cloud of gas and dust known as a nebula. A vast, chilling expanse of interstellar lullaby as cold as -260 degrees Celsius and mostly static. It's hard to imagine such a tranquil beginning to the vibrant, celestial ballet that is our solar system. Yet, in this cosmic cradle, the seeds of our solar system were sown. Tiny gravitational fluctuations, perhaps whispers from distant supernovae or the ripples of passing stars, tugged at the edges of the cloud. They nudged the nebula into a state of transformation. The whispering cosmic forces didn't violently crash the nebula but subtly rippled through it, setting the stage for an epic evolution. The effects of this cosmic nudge were profound. The gentle ripple compressed the gas and dust, making the cloud denser and warmer. Gravity, the unseen maestro of the universe, took center stage. It conducted the nebula's transformation, orchestrating a symphony of cosmic forces that would eventually give birth to a star, our sun. This nebula, our celestial home's birthplace, was not a scene of chaos and destruction, but a stage of gentle, gradual transformation. The nebula's gases and dust particles, under the deft guidance of gravity, began to compress and heat up. This interstellar dance of matter and energy, stirred by the delicate baton of gravity, set the stage for the formation of a stellar embryo, a protostar. And so, the cosmic dance continued, shaping, transforming, and evolving. Each movement, guided by the unseen hand of gravity, was a step closer to the birth of our solar system. Each ripple, each whisper, each nudge was a note in the celestial symphony that would eventually give rise to our sun and all the planets that orbit it. This cosmic nudge, although subtle and not a violent crash, set the stage for the birth of our solar system. It's a reminder that even the smallest of forces can drive the most profound transformations, shaping the universe's course and giving birth to wonders beyond our wildest dreams. As the cloud collapsed, its core grew hot and dense, forming a stellar embryo we call a protostar. This was no ordinary birth. Like an avian phoenix rising from the ashes, the protostar emerged from the cold, static nebula, radiating with the promise of a new star. Inside this fiery cocoon, conditions were extreme. The pressure and temperature soared to levels beyond our earthly comprehension, reaching millions of degrees Celsius. It's a bit like the world's most intense pressure cooker, but instead of cooking up a hearty stew, it was cooking up the raw materials of a star. In this extreme environment, the universe's most abundant element, hydrogen, began a dance of transformation. Hydrogen atoms, eager for companionship, started fusing into helium. This process, known as nuclear fusion, released a torrent of energy that heated the protostar even more. This was not a quick waltz around the dance floor, oh no. This was a cosmic ballet that spanned millions of years. With each passing eon, the protostar grew hotter and denser. The dance of the atoms within its core quickened, their fiery pirouettes casting an ever brighter glow. Finally, the protostar reached a critical point. Its core temperature and pressure became high enough to sustain a stable nuclear fusion reaction. This was the moment of truth, the culmination of millions of years of cosmic ballet. With a final resounding crescendo, the protostar ignited. In that moment of stellar ignition, the protostar transformed. It was no longer a stellar embryo, a fiery cocoon harboring the potential of a star. It was now a radiant, glowing star shining with the light of a billion suns. It was, in short, the sun. This was a pivotal moment in the birth of our solar system. The sun, with its radiant glow and gravitational pull, would serve as the heart of our cosmic family, nurturing and guiding the planets in their celestial dance. After millions of years, the protostar ignited, transforming into the radiant star we know and love, the sun. And so, the stage was set for the next act in this cosmic ballet, the dance of the protoplanetary disk. But that, my friends, is a tale for another time. With the sun ablaze at the center, the remaining disk of gas and dust began to clump and dance. This dance is no ordinary ballet, but a cosmic performance choreographed by the forces of gravity and heat. As the scene unfolds, we see smaller particles in the disk, these tiny dancers of the cosmos, colliding and sticking together. Each collision, each connection creates something larger, something more substantial. This is a dance of creation, a dance of growth. The gas and dust, the dancers of our story, are not evenly spread across this cosmic stage. Closer to the sun, where the heat is intense and the gravity strong, we find rocky materials. These hardy performers, unyielding under the sun's relentless glare, begin to come together. They collide, they combine, and in the fiery heat and crushing gravity of this inner circle, they form something new. From these rocky materials, the inner planets start to take shape. Each one a testament to the power of this cosmic dance, each one a testament to the power of creation. First we see Mercury, a celestial sprinter forever zipping around the sun, emerging as the solar system's smallest and swiftest planet. Next, Venus, enveloped in a veil of swirling gases, takes its place on the cosmic stage. Then, bathed in the sun's golden glow, Earth takes shape. This celestial oasis, our home, is born from the dance of the protoplanetary disk. Finally, Mars, the rusty warrior of the inner solar system, emerges as a cold, dusty world. This dance, this cosmic performance is not just a spectacle to behold, it is a testament to the power of the universe, to the wonder of creation. It is a dance that has shaped our world, that has shaped our solar system, and it is a dance that continues to this day, shaping and reshaping the cosmos as we know it. This dance of the protoplanetary disk gave birth to Mercury, Venus, Earth, and Mars. This is a dance of creation, a dance of growth, a dance of life, and it all started with a little gas, a little dust, and a whole lot of gravity. Beyond the orbit of Mars, where the sun's gravity weakened and temperatures dipped, the gas giants reigned supreme. Here in the outer solar system, far from the sun's warmth, the conditions were just right for the birth of gas giants, Jupiter and Saturn. As we journey away from the sun, the solar system's stage changes dramatically. The sun's heat diminishes, and the cosmic dust and gas that were once scattered now swirl together, forming a denser, colder environment. In this icy realm, the elements that were scarce closer to the sun, namely hydrogen and helium, become the dominant players. The formation of the gas giants is a fascinating tale of cosmic proportions. Imagine a massive disk of gas and dust spinning in the cold expanse of space. Within this disk, small clumps of matter begin to collide and stick together, growing ever larger. These burgeoning cores, rich in ice and rock, act like cosmic hoovers, sweeping up the surrounding gas and dust. Jupiter, the largest of the gas giants, was likely the first to form. Its enormous size suggests it began collecting matter early in the solar system's history, growing rapidly into a giant. With its massive gravitational pull, it was able to hold on to the lightest elements, hydrogen and helium, which formed the bulk of its composition. Not far from Jupiter, another core was growing. Saturn, though smaller than Jupiter, is still a giant among planets. Its beautiful rings, composed of countless particles of ice and rock, are a testament to the power of gravity and the abundant materials present during its formation. These two gas giants, Jupiter and Saturn, are unique in their size and composition. They are the heaviest of the planets. Their massive size is testament to the wealth of material available in the outer solar system. Their reign is uncontested, their presence a reminder of the early solar system and the processes that shaped it. From the swirling masses of hydrogen and helium, Jupiter and Saturn emerged, the ruling titans of the outer solar system. Their reign stands as a testament to the power of gravity and the abundant materials present in the early solar system. The reign of the gas giants is a fascinating chapter in our cosmic story, a story that continues to unfold before our eyes. As the sun's light dimmed and temperatures plummeted at the outermost reaches of the solar system, two icy titans stirred from the cosmic leftovers. Beyond the orbit of Mars, where the sun's gravity weakens and temperatures dip, hydrogen and helium reign supreme. These are the ingredients that gave rise to the gas giants, Jupiter and Saturn. But even further out, where the sun's warmth is but a whisper, another duo of titans were taking shape. Uranus and Neptune, our solar system's icy giants, were born in these frigid outskirts. These planets, composed primarily of heavy elements, are enshrouded in thick atmospheres of hydrogen, helium, and methane. The methane in their atmospheres absorbs red light, giving these distant planets their signature blue-green hues. But don't let their serene colors fool you. Their interiors are turbulent, with temperatures and pressures that far surpass those on Earth. But Uranus and Neptune weren't the only ones to emerge from the cosmic leftovers. There were also the smaller yet no less significant celestial bodies, the asteroids, comets, and dwarf planets. These cosmic relics serve as a window into the past, offering clues about the early solar system. Asteroids, the rocky remnants from the solar system's formation, are scattered primarily in the asteroid belt between Mars and Jupiter. Comets, icy wanderers of the solar system, originate in the distant regions of the Kuiper belt and the Oort cloud. When these dirty snowballs approach the sun, their ices vaporize, creating glowing comas and dazzling tails that light up our night skies. And then, there are the dwarf planets. Worlds not quite big enough to be considered full-fledged planets. The most famous of these is perhaps Pluto, a tiny icy world that resides in the chilly Kuiper Belt. From the cosmic leftovers, Uranus, Neptune, and countless other celestial objects continue their endless waltz around the sun. These icy titans and cosmic leftovers, each with their own stories to tell, remind us that our solar system is a diverse and fascinating cosmic family. The birth of our solar system isn't just a historical event, it's a story that continues to play out. Just as it was born from a cosmic dance of gas, dust, and gravity, so too does it continue to evolve. Each celestial body, from the smallest asteroid to the largest gas giant, is part of this ongoing cosmic ballet, forever influenced by the unseen hand of gravity. Our sun, though mature, is a dynamic entity, its magnetic fields and solar winds constantly shaping the space environment. Even the planets, including our home, Earth, are always changing, their surfaces reshaped by geological activity, weather, and even the impact of stray celestial bodies. As you look up at the night sky, each twinkling star, each streaking comet, each silent, distant planet is a reminder of this cosmic saga. So next time you gaze at the night sky, remember you're witnessing a cosmic birth, a story that continues to be written in the vast canvas of the universe. If you enjoyed this journey, don't forget to like, comment, and share.